Welcome to this exploration of ultraviolet light. Ultraviolet, often abbreviated as UV, is a fascinating form of electromagnetic radiation that exists just beyond the violet end of the visible spectrum. The term ultraviolet literally means beyond violet, indicating its position in the electromagnetic spectrum. Throughout this presentation, we'll discover what UV light is, where it comes from, and how it affects our daily lives in both beneficial and harmful ways. Ultraviolet light is a type of electromagnetic radiation with wavelengths shorter than visible light but longer than X-rays. Human eyes cannot detect UV light because its wavelengths fall outside our visible range. The wavelength range of ultraviolet radiation spans from 10 nanometers to 400 nanometers. To put this in perspective, violet light, which is the shortest wavelength we can see, ends at around 400 nanometers, and ultraviolet light begins right where violet ends. This invisible radiation carries more energy than visible light due to its shorter wavelength. Ultraviolet radiation is divided into three categories based on wavelength. UVA has the longest wavelength, ranging from 315 to 400 nanometers. It penetrates deep into the skin and is primarily responsible for skin aging and long-term damage. UVB has a medium wavelength, from 280 to 315 nanometers. This type causes sunburn and plays a crucial role in vitamin D production in our bodies. UVC has the shortest wavelength, from 100 to 280 nanometers. It is the most dangerous type, but fortunately, Earth's ozone layer absorbs nearly all UVC radiation before it reaches the surface. Ultraviolet radiation comes from both natural and artificial sources. The primary natural source is the sun, which emits all three types of UV radiation. UVA, UVB, and UVC, however, as mentioned earlier, the ozone layer filters out most UVC and some UVB before it reaches us. Artificial sources include UV lamps used in various applications, tanning beds that emit controlled amounts of UVA and UVB, black lights that make fluorescent materials glow, and germicidal lamps that use UVC for sterilization purposes. Despite its potential dangers, ultraviolet radiation provides several important benefits. The most well-known benefit is vitamin D production. When UVB rays strike our skin, they trigger a chemical reaction that produces vitamin D, which is essential for bone health, calcium absorption, and proper immune system function. UV radiation is also used in medical treatments for various skin conditions such as psoriasis and eczema, a process called phototherapy. Additionally, UVC radiation is highly effective for sterilization and disinfection. It destroys the DNA of bacteria, viruses, and other microorganisms, making it invaluable for purifying water, sterilizing air, and disinfecting surfaces in hospitals and laboratories. While UV radiation has benefits, overexposure can cause significant harm to human health. Sunburn is the most immediate and visible effect, caused by excessive UVB exposure that damages skin cells and triggers an inflammatory response. UV radiation can also damage the eyes, leading to conditions such as cataracts, which cloud the lens of the eye, and photokeratitis, essentially a sunburn of the cornea. The most serious long-term risk is skin cancer. Prolonged UV exposure damages the DNA in skin cells, potentially leading to mutations that cause cancer. UV radiation also accelerates skin aging, causing wrinkles, age spots, and loss of skin elasticity. Protecting yourself from harmful UV radiation is essential for maintaining health. Sunscreen is the first line of defense. Use broad-spectrum sunscreen with an SPF rating of 30 or higher, which protects against both UVA and UVB rays. Wear sunglasses that offer 100% UV protection to shield your eyes from damage. Protective clothing, such as long-sleeved shirts, pants, and wide-brimmed hats, provides a physical barrier against UV rays. Finally, seek shade and avoid prolonged sun exposure during peak UV hours, typically between 10 a.m. and 4 p.m., when the sun's rays are strongest and most direct. Ultraviolet light has numerous practical applications across various fields. In water purification, UVC radiation effectively kills bacteria, viruses, and other pathogens without adding chemicals, making water safe to drink. UV light is used in counterfeit detection, as it reveals hidden security features in currency, passports, and official documents that are invisible under normal light. Forensic scientists use UV light to detect bodily fluids, fingerprints, and other trace evidence at crime scenes. Finally, UV radiation causes fluorescence in certain materials, making them glow. This property is used in everything from blacklight posters and entertainment venues to scientific research and mineral identification. These diverse applications demonstrate how ultraviolet light, though invisible to our eyes, plays a vital role in modern technology and everyday life.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.